All right. Like, we're not going to tell them. All right, so a little review of what we did last time. The last section in chapter 4, the binomial. Okay. Yeah. Anybody else need? Me. One side was the answer key for that practice problem. Everybody. So yeah, one side was the answer key for that practice quiz. The other side is the one we're going to talk about in a minute. So we actually did talk about these first three things. I didn't show you the good old variable for this. So the variable for binomial probability is going to be how many successes there are. That's what can change. So if I'm looking for rabbit squirrels, and the success is finding a rabbit squirrel, and the number of rabbit squirrels would be X, right? So X is the variable because it's the number of successes. That's the thing that can vary. So if I pick 25 squirrels, how many of them could be rabid? Anywhere from 0 to 25. I love it. Cool. People always figure out 0. Thankfully, it could be no rabid squirrels in my little collection. Everybody, that's good. Oh, you. All right, and we actually developed the formula for this last time. I don't think I put it all together for you, but there was a piece that told me how long the list was going to be. Right? How long the list would be. So we did a very simple example where the list was really short, just to see how it's put together. And then I think in the next example we had the calculator tell us it would have been 185,000 or something like that long. I don't want to make that list, right? And they can easily get up in the millions, and I'm like, okay, that's crazy. And that we discovered is this NC, and I call it NCX. I know the calculator says NCR, but oh well, we disagree. N choose X, because I use X for the, and not just me, basically everybody except the calculator. I use X for the number of successes.
That would be confusing.
You'll be okay. You'll forget about it. The main thing you worry about when you go to the calculator to put this in is the C. That's all you really can. You want to pick the one that's C. Choose. Not NPR, National Public Radio. You don't care about it. That's got something to do with what's called permutations, right? How many ways can you rearrange something? This is how many ways can you choose something. It's a little more basic. And then the next thing was times how many successes do I want? Well, by definition, it's X. I want X of these. And here's the part that's going to be a little weird. So I think the example we did last time was something like there were, I wish I could remember. So if I had like 11 people, and the probability of success is 0.7, and I wanted the probability I get 2 successes. Right? To set this up, this would be 11 choose 2 to see how long the list would be. How many 0.7s do I want? Well, I want 2 of them. So how many 0.3s do I, where did I get 0.3 from, by the way? Where did 0.3 come from? I love you guys. You have such a pained look on your face. But here's a little example I'm doing. Sort of like what we did last time. Just to remind us what we managed to get through. If I had 11 people and the probability of success was 0.7, whatever this is, probably getting somebody who will develop arthritis. I don't know. Whatever. Yes. Are you good? You're just going like this, like, oh shit. Sorry, it's very confusing to me. 2 successes, the probability of failure has to be 0.3. P plus Q must be 1 because they're opposites. So how many of those do I want? How many of those do I have to have? No. How many people do I have? 11. How many of them are going to be successes? How many will be successes? 2. So how many failures must that mean I'm going to have? 9. Okay, come on. Right? Please don't make too big of a deal out of that. Those powers add up to be the total because you are breaking your total up into 2 groups. The successes and the failures. Right? Success and failure don't mean good, bad. Rabbit, squirrel, I don't think I would consider that to be good. Success is just what I'm looking for. Right? Dead body on the battlefield, or I'm looking for a good grade. That's good, but dead body, not so good. Yes?
Can I just clarify the C sits above?
Yeah, the just the way that this notation works for this is the subscripts are in front and back. So I love that because of the way you would say it. How many? I got 11 people. I'm going to choose 2 of them to do this thing. So I have 2 successes, 2 people doing what I'm looking for. That must mean the other 9 are doing something else. Right? They're failures. Crazy people. I like it. So now look. So here's the choose piece. N choose X. The total number I want to choose this many to be a success. So how many of these do I want? X of them. I want X successes. Why am I saying success when I look at P? What is P? Probably a success. Kick ass. So how many Q's do I want? This is where the formula gets worse than the actuality is. What's left over? If X are successes and there are N total, what's left? N minus X. I love it. In practice, it's easy as shit, please. If there's 2 here and there's 11 total, then there must be 9 there. The formula has to be all-encompassing, so it always kind of looks a little worse than the reality. Okay, so let's try a full problem out, and then I'm going to let you guys attack this handout. Yes? Say again? Yes, beautiful. What do I need to know to do this problem? I need to know N. Well, N is 11. I need to know P. Well, that's 0.7. They don't have to tell me Q as long as they tell me P, because Q is the opposite of P. So what would Q have to be? The rest. If P is 70%, Q has to be 30%. I love it. Kick ass. And in this case, I want 2 successes. So I highly recommend that when you get a problem involving binomial situation, you identify these things before you set up any equations, because that's the stuff you're going to have to plug in. Now, I explained to you, and we actually did some problems that showed you where this formula came from last time. Right, we did the derivation of the formula. I know a lot of people hate that part. They're just like, just show me where to plug shit just so I can get out of here. But the idea was discussed last time. There's an idea behind this, and it actually kind of flows as a sentence. I want to have this many. I want to choose this many to be successes, so I get this many successes. The rest are failures. I mean, that's how it gets put together. It's crazy. Okay, so let's try a problem out. It freaked me out the first time I did that. All right. Take this over here. Leave that there for you. So let's say I have, what do you got? Oh, let me do something off the quiz. There was a 28% chance, you gotta love this one, whoever had this one, that 20% of men are dissatisfied with the position of women in society. Now, to be honest, that doesn't mean that they're little shits. They could be dissatisfied because they think that they should have a better position in society, right? I have a feeling that a lot of these are old leftovers that are like, they shouldn't be talking to me. Do you see how that's kind of leading you in the direction of a binomial situation? Why? Because binomial inherently means 2 cases, right? So either the men could be dissatisfied or not, right? So what would P be for this problem? I could identify it already. 0.28. What would Q be? 0.72. I love it. So now if I say we take, what do you got, Jeff? 27 men. What's the probability that, let's see, what's going to be good here, Jeff? Yeah, sure. Probably that exactly 7 of them are dissatisfied. Hopefully I spell that close to right. We'll see. You understand the basic idea of the question there? If I just take 27 randomly selected men, what's the probability that exactly 7 of them feel this way, right? And this seems, we're just getting used to the setup. We're just getting used to what it sounds like. We're getting used to what the formula works like. But like I said last time, if I had enough information, I could use the probability to figure out, well, how many should we overbook this plane for? So we have a higher chance of it being full, but a smaller chance of having bad PR because we have to bump upon a bunch of people. You guys with me? And we learned what bump meant, which you should feel happy. You don't know what that means. It sucks to be on the other end of that when it's not a choice. So what do I got? I got PQ. What can I identify now? What 2 things can I identify now? From what I've told you down here. What do you know? What's 27? N. N is pretty much always, throughout all of statistics, the total number, thank God. What's 7? X. It's how many successes I want. Right? I don't know why you guys always choose to sit there, but I'm going to. Okay. So X is 7. Now I can build the formula. I can just plug stuff in to the formula. So we got, let's see, how does this formula get built? The probability of 7 will be, try to set it up. Try to set up what that formula would look like. Put things in the right place. I'm going to wake this guy back up. There you go. That's interesting. I'm a little concerned. One of these buttons says camera feed. I don't like it. Somebody's watching. Alright, so before I turn that around, power. Somebody help me out. How does this get set up? What's it going to look like? 27 people. Choose 7 of them to do this. What's P? So 0.28, how many of those you want? 7. That's crazy. We just said that. I like how it repeats itself. So how many of the other thing you want? 20. If there's 7 there, 27 total, it must be 20. If the formula freaks you out, screw the formula. It's just that easy. It's easier just to think about it. It's sort of like the probability formula is getting in our way. I'm not bad-mouthing formulas, by the way. It's just you got to know when they are useful and when they are not. So how does this look like in the calculator? I should pay a TA just to sit here and move my camera around. Poor little thing. Okay, here we go. You ready? So I would do, you always put the number you want first. That's why it's subscript, the first subscript. So 27. Remember where that NCR thing is. Let me zoom out a little bit. Math. Probability. Oh, you gotta love those spots. There you go, Jeff. Probability. Yeah, not that one. That. Choose 7. Now, if you have the newer calculator, you got to hit over to get the heck up out of the subscript. If you're not used to it yet, you're going to be writing a lot of stuff down there, and it's going to go syntax error. You got to hit that over button to get up. If you got an older calculator, You don't have to worry about all that crap, but yours doesn't look as nice. Times, help you guys out, 0.28 to the 7. Hit the over arrow to come the hell down out of the exponent. You guys see that? It's giving you hints, like hit the over arrow, okay? Times 0.72 to the 20th. So that's what it looks like in the calculator. Your NCX, P to the X, Q to the N minus X. So see if we all get the same thing. I get that. If you had to write that rounded to 4 places, what would it look like? Good, 0.1680. It's that simple. Man, people freak out about that, but it's 79 closer. It's 79.5 closer to 80 or 79. It's closer to freaking 80. So 0.1680. Okay, cool. I like it. I like it. So it's possible some of you guys already started looking at this, but I want you to go ahead and do this. You've already done it. Maybe you can help out somebody near you. Don't just tell them what the freaking answers are. Help them.
What are the answers?
Yeah.